Welcome to Last Human Era. I am absolutely thrilled you're joining me today because we are going to dive into a truly mind-bending hypothetical scenario. Have you ever wondered what would happen if our celestial companion, the Moon, just suddenly ceased to exist? Well, in this explainer, we're going to track exactly how a suddenly moonless Earth would transform, literally, from the very first night all the way to 1,000,000 years into the future.
Seriously, think about it. What if you looked up at the night sky tonight and the moon was simply gone? No explosion, no warning, no cosmic debris, just an empty dark space where it had existed for billions of years. At first, many people might think it's just a weird optical illusion, but within hours, astronomers and scientists worldwide would confirm the impossible. Earth's only natural satellite had completely vanished. The nights would become much darker, sure, but honestly, that would be the absolute least of our worries. The moon stabilizes Earth's tilt and controls our ocean tides, meaning its disappearance could trigger some dramatic environmental changes right across the planet.
Now, before we trace this wild aftermath, let's quickly address why this has to be a magical vanishing act. Actually blowing up the moon in real life, it's virtually impossible. To completely destroy it so that its own gravity doesn't just pull all that debris right back together into a brand new satellite, you would need an unfathomable amount of energy. We're talking roughly 1.2 times 10 to the 29th power joules.
And this brilliantly illustrates just how massive that number is. To reach that amount of energy, you need the equivalent of 600 billion 50 megaton Tsar bombas. That's the largest nuclear weapon ever detonated by humanity. To put it another way, it's roughly equivalent to the full energy output of our sun over 6 entire minutes. Absolutely mind-blowing. So, since a cosmic demolition of that scale just isn't happening, let's assume the moon simply vanishes. Oh, and before we continue, if you're enjoying these mind-bending future scenarios, make sure to like this explainer, share it with someone who loves science, and subscribe to Last Human Era for more incredible journeys into the future.
All right, here is the blueprint of our moonless Earth. We'll start with a sudden disappearance, track the immediate changes in the oceans, explore the impact on Earth's life, see how it alters our planet's spin and time, and finally, dive into the great axial tilt debate.
Okay, let's dive into this, starting right at the beginning, the immediate aftermath of a suddenly missing moon. The disappearance would send shockwaves through our environment on a massive timeline. Immediately, our nights would become eerily dark, illuminated only by starlight. Within weeks, marine ecosystems would begin to fundamentally shift, and stretching out over millions of years, the very tilt of our planet could radically alter. While astronomers raced to solve the greatest mystery in human history, asking, where did the moon go? Was it an unknown cosmic force? Did an advanced civilization remove it for a reason humanity cannot yet understand? The rest of us would be dealing with the physical realities here on Earth.
So, let's move into those first few weeks and take a close look at the changes in the oceans, where we'd be left with just a quarter of our normal tidal rhythm.
Without lunar gravity, our oceans would radically change. Now, tides wouldn't stop completely because the sun's gravity is still pulling on our oceans. But compared to the combined solar and lunar tides we're used to, a solar-only tide would drop to just a quarter of the size of our current spring tides.
As weeks turn into months, these drastically weaker tides would devastate coastal ecosystems. We're talking a massive reduction in the exchange of water, nutrients, and oxygen. Shorelines would physically alter, and intertidal habitats, those crucial zones that rely on being regularly washed by the tides, would dramatically shrink. Countless marine ecosystems could literally collapse, as the shellfish and algae adapted to those zones fail to survive.
But it's not just the oceans. Let's zoom out a bit and look at the immediate biological chaos on land, specifically for predators and prey navigating in the dark.
You see, animals that rely on moonlight for navigation would really struggle to survive. The sudden loss of moonlight completely scrambles the playbook for nocturnal creatures. For predators like owls and big cats that rely heavily on the moon to spot their next meal, the ambient light would drop off a cliff. Visual hunting would become incredibly difficult, forcing these predators to fall back on smell or hearing, or maybe even change their hunting times entirely to dusk and dawn.
But on the flip side, prey animals would experience a completely different reality. An analysis by the Times of India actually noted that prey animals often hide during bright nights to lower their risk of being detected. Well, without moonlight, that limitation totally vanishes. Prey animals would likely surge in nocturnal activity, fundamentally unbalancing global food chains and potentially overgrazing vegetation in the newfound safety of true darkness.
Let's shift gears from biology to long-term physics. We're going to unlock Earth's rotation and see how the moon affects our spin and our very concept of time.
Historically, the moon has acted like a giant gravitational brake on our planet. Its asymmetric mass distribution pulls on Earth's tidal bulges, exerting a net torque that literally slows us down. Because of this tidal friction, the moon lengthens Earth's day by about 2 milliseconds every single century. It's achingly slow, sure, but over geological time, it hugely matters.
Let's move to this comparison and see how it builds over time. When our planet was young and the moon first formed, a single day on Earth was less than 10 hours long. Today, obviously, it's 24 hours. Now, if the moon vanished, our rotation wouldn't just suddenly speed back up. Instead, it would stop slowing down as quickly, because that dominant braking force would be totally gone, leaving behind only the sun's much weaker tides. And now we enter the final, deep time section, the heavy physics of planetary habitability and the great axial tilt debate. Because without the moon, Earth's seasons might become increasingly unpredictable.
For a long time, the strict scientific consensus was that the moon was absolutely essential for keeping our seasons stable. A classic 1993 model by Lasker and Robutel argued that without the moon, Earth's axial tilt could oscillate chaotically from 0 degrees all the way to 45, or possibly even 85 degrees. I mean, that would mean catastrophic, climate-destroying wobbles over millions of years.
The mechanics behind this involve a concept called precession. Basically, other planets exert a gravitational pull on Earth's orbit. But the moon's gravity induces a very fast rate of precession for Earth, about 50 seconds of arc per year. This fast wobble acts sort of like a stabilizer on a spinning top, keeping us safely out of a chaotic resonance with all those other planets.
However, science is never entirely settled. More recent models suggest a fascinating counter-argument. A 2013 paper by David Waltham neutrally presented the idea that our moon actually pushes us closer to instability. His argument is that because the moon's tidal drag slows our rotation, it actually reduces our precession over time, potentially accelerating our evolution toward that dangerous resonance.
Now, what's really interesting about this data is the boundary it shows between a stable and an unstable tilt. If you chart normalized lunar mass against normalized angular momentum, the Earth-Moon system sits right on the edge of instability. It's an incredibly precarious position.
The margin is literally razor thin. According to this newer model, an Earth with just a 9% heavier moon, or starting with just 8% less angular momentum, would have developed a chaotic, unstable tilt after 4.5 billion years. It really proves that our celestial companion represents a delicate, almost miraculous balancing act in our solar system.
So the crucial point here is the sheer scale of human systems that would permanently break down without the moon. We'd see massive, permanent disruptions to coastal shipping and harbor management because of the altered tides. Nighttime navigation and security would plunge into true darkness. Lunar calendars, which are foundational to so many global cultures and agricultural systems, would lose their astronomical anchor. And in the long term, we lose the climatic stability we rely on for our crops. Ultimately, the moon's disappearance wouldn't just change our skies. It could reshape our future, challenge everything we know about the universe, and remind us how dependent we are on a celestial companion we've always taken for granted. I mean, if the moon disappeared once, what could vanish next? And if these future possibilities fascinate you, don't forget to like this explainer, share it with your friends, and subscribe to Last Human Era, because every week we explore the most unbelievable futures humanity may face.
Which brings us to the end of our hypothetical journey today. But if you woke up tomorrow and the moon had vanished forever, what do you think would be the first sign that something was terribly wrong? Let me know your theory in the comments.